Good morning, everyone. It's your teacher, Ms. Samara Imran Malik, and today we are diving into a fundamental concepts in physics that affect almost everything we see moving around us. That is air resistance. Whether you are watching a bird glide through the sky, a race car speeding down a track, or a snowflake gently drifting to the ground, you people are witnessing the effect of air resistance in action. Today we will be focused on your book section 10.3, that is air resistance, from chapter number 10, it's force and motion. Our goal today is to look beyond what our eyes see and understand the invisible forces at play. We often think of air as empty spaces, but to a physicist or a scientist, air is a thick soup of particles that every moving object must push through. Today, we will explore why some things fall faster than others, how shapes can be designed to cut through the air, and why a parachute can save a life. Let's get started and see how the air around us constantly pushes back. Before we jump into the mechanics, let's look at our roadmap for this session. So, our learning objective are strictly aligned according to your topic. Firstly, we will describe how exactly air resistance is produced. We will look the Coulomb theory between object and the air particles. Secondly, we will identify where air resistance is a problem, like slowing down the cars, and where it is actually a life-saving tool, such as in parachuting. Thirdly, we will take a trip to the moon, metaphorically, to explain what happens in the vacuum and why the absence of the air changes everything we know about falling objects. We will also investigate the three major factors that affect the strength of this force, that affect the strength of air resistance. That is, these factors are speed, surface area, and shape. Finally, we will put all this theory into the practice by solving real questions that are given into your books, ensuring that you have a correct scientific terminologies like drag and opposing force, and you people will get ready for your um, exams as well. What is air resistance? Let's start with a clear definition. When any object moves through the atmosphere, it experiences a force called air resistance, which scientists also refer to as drag force. It is a vital part to understand that air resistance is a specific type of friction. Just like your shoes rub against the floor to create friction, an object rub against the air. The most important rule to remember is that air resistance always opposes motion. If you are running forward, air resistance is pushing you backward. It never helps you go faster. It always tries to slow you down. But why does this happen? It is because air is not nothing. It is made up of billions of tiny gas particles, air particles. As you move, you physically collide with these particles, and each collision is a tiny hit that pushes against you. So, individually, one air molecule doesn't do much, but when you are hitting trillions of them every second, those trillion hits, those trillion tiny hits, add up to a significant force that you can feel, especially when you stick your hand out of a moving car window. You can easily experience that air resistance. So, to understand the air resistance, we need to use our uh, scientific concepts, like to see the particle model theory that we already have discussed in your previous level E2. Imagine a crowded hallway, and if you try to run through it, you will bump into people, and each bump slows you down. Air is the same like that. An object moving through the air must shove air particles, air molecules out of its way. So, the faster you move, the harder and more frequently you hit these particles, you hit these molecules, air molecules. This is why air resistance isn't a constant force, it grows as you speed up. Think about a cyclist. At a very slow pace, they hardly feel the wind. But as they pedal faster, the wind, which is actually the air resistance, that air resistance becomes a powerful wall that have to push against him. So, in physical terms, the object exerts a force on the air particle to move them, and according to Newton's law, the air particles exert an equal and opposite force back onto the object. This pushback is what we measure as a drag force or a friction or the air resistance that we can say. Now, the term factors affecting air resistance. The first major factor is speed. So there is a direct mathematical relationship here. As the speed of an object increases, the air resistance increases as well. But why? Because at higher speed, the object is hitting more air particles per second, and it is hitting them with much greater kinetic energy, moving energy. Kinetic energy is the moving energy. So think about a car like which is driving at 20 kilometer per hour versus 100 kilometers per hour. And at 20 kilometer per hour, the engine does not have to work very hard to overcome the air. But at 100 kilometer per hour, the air resistance is many times stronger. This is why cars use significantly more fuel when driving fast on a highway, and the engine is fighting a much stronger invisible wall of air. Eventually, for falling objects, the force can become so strong that it perfectly balances the pull of gravity. When the upward air resistance equals to the downward weight, the object stops accelerating, its speed decreases, and reaches what we call its terminal velocity. Next factor is the surface area. So, this is essentially how much frontage an object has facing the wind. The front area, the front side of an object is facing the wind. We are talking about that surface area. So, which surface area? The front part of that object which is moving, that area when it is in contact with the air. So, a larger surface area means the object will collide with a much greater number of air particles at the same time. Let's use a simple analogy. So, and imagine walking through a rainstorm holding a needle versus holding a large umbrella. So, the umbrella, obviously having a large surface area, it catches away more raindrops than the needle. Similarly, a flat sheet of paper falls slowly because its large surface area catches many air particles, creating a lot of upward push as well. However, if you crumple that same paper into a tight ball, you haven't changed its weight, but you have fewer air particles on its way now by decreasing its surface area. This is the exact principle behind parachutes as well. We want as much surface area as possible to maximize the air resistance and slow the fall to a safe speed. The next is its shape, streamlining shape. So the final factor is its shape, and this brings us to the concept of streamlining. If you look at the modern high speed train or a racing car, high speed train, like you can have an image of maglev train in your mind, and a racing car or even a shark, you will notice that they all have similar teardrop or a pointed shape like fish. This is not just for aesthetics, it's functional. A streamlined shape is designed to allow air particles to flow smoothly over the surface rather than crashing into it. Imagine a flat, blunt truck. So, when it is moving through the air, It hits the air particles like a wall, creating huge amount of friction and air resistance and drag force. Now imagine a pointed sports car. It cuts through the air, gently nudging the particles aside. By reducing the hit and allowing smooth flow, we can move much faster using much less energy. In nature, birds have evolved streamlined bodies to hunt efficiently. And in engineering, we spend millions of dollars in wind tunnel trying to make planes and cars as streamlined as possible to save on fuel cost. The next is useful air resistance. Now, the wind tunnel testing and cyclists and athletes. So, car manufacturers use wind tunnels to test those streamlining, and in these tunnels, smoke shows the path of air. And smooth flow means good streamlining, and streamlined cars use less fuel, you can say. And if we talk about cyclists and athletes, so cyclists pull in their arms and crouch forward to reduce contact area with air. And they are also having a special helmets, make them more streamlined to reduce drag force or the air resistance. So streamlining is about the shape design. Nature has been doing it for millions of years through evolution as well. The next thing is parachutes and braking. We often talk about the air resistance as a problem because it slows things down. But we often talk about air resistance as a slowing down things, and but sometimes it's slowing down is exactly what we need to stay alive. You can say it's very useful for us. The most famous application of useful air resistance is the parachute. So when a skydiver jumps from a plane, gravity pulls them down and they accelerate rapidly. They move very speedily. Accelerate means their speed is now continuously increasing due to that gravitational pull from the gravity from the earth. So without a parachute, they would hit the ground at a lethal speed. They can be, so it will be very harmful for them. However, when the parachute opens, it creates a massive increase in the surface area as compared to the person's body. Suddenly, instead of a small human shape falling, you have a giant canopy catching thousands of air particles every second, and this creates a massive upward force of air resistance as well that opposes the downward pull of a gravity, that opposes that gravity, because it is against that air resistance. uh, Move that parachute upward, or make hindrance in its falling speed. So this creates a massive upward force of air resistance that opposes the downward pull of gravity, and a skydiver quickly slows down until they reach a much lower level safely with a terminal velocity, with a safe velocity. It's a perfect example of how engineers use the laws of physics to turn a hindering force into a life saving tool. It is also used in like rocket car braking and aircraft flaps. Now, what aircraft flaps are doing over there? They spread aircrafts have a spreaded flaps to increase the air resistance when they are landing, as well as some rocket cars use parachutes to brake at very high speed to reduce their speed. To so in these cases, you can say that the air resistance is a very useful effect for that. So you have to learn some key points or the key concepts. Sometimes we want air resistant and it keeps us safe, like parachutes, like air flaps, like rocket car brakes. All of these engineering products use the resistance to slow down things, and air resistance is not always a problem. It can be a life-saving force when used correctly. Now, if you say that what is the terminal velocity, what is its key definition for that? So the constant maximum speed when air resistance equals the weight. Constant maximum speed when air resistance equals the weight. When air resistance uh, opposes its motion, opposes its speed, which was due to the gravity and it was very high. But when these two opposing force equalize each other, normalize each other, cancels each other effect, then the object get a terminal velocity. So this velocity is a constant maximum speed with a safe a mode, you can say, and the object, whatever it is, it can hit the ground. So terminal velocity is equals to balanced forces. Which force is gravitational force and its moving velocity force, weight and air resistance. These two forces will balance each other. Parachute creates new lower terminal velocity and heavier objects have higher terminal velocity. Got it? So terminal velocity, what it is? It's a constant maximum speed when air resistance equals to its weight. Clear? Now, what the parachutist actually do during its jump? Firstly, when he jumps, so its weight is greater than the air resistance. Its gravitational pull is greater than its air resistance. So it's speeding up. When it's speeding up, and he also has opened its parachute, so similarly at the same point air resistance also increases, and eventually that parachutist got a terminal velocity where air resistance becomes equal to its weight. When he opens the parachute, now he is going to open the parachute and air resistance becomes greater than its weight, showing now air resistance is greater as compared to its weight. It slows down. Now it's slowing down. Its speed is decreasing now, which shows that now air resistance decreases and he eventually got a terminal velocity and lands safely. Do heavier things fall faster? So So, what would happen if you took all the air away? Do heavier things like fall faster on Earth with air resistance? What's going on there? And in vacuum with no air resistance? Firstly, we are just going to be focused on the main points that actually what vacuum is. Then we will move towards its comparison. So, what would happen if you look at the air away? This is what we call a vacuum. When you suck up all of the air from any tunnel or in a tube, any jar, any container, when nothing leaving behind makes it a vacuum. In a vacuum, there are no particles. No particles mean no gases like nitrogen, oxygen, carbon dioxide. There is nothing over there. And if there are no particles, there can be no collision. When anything moving from that having no hindrance over there, and if there are no collisions, there is zero air resistance, you can say. This leads to a counter fact of physics, like in a vacuum a hammer and feather will fall at the exact same rate. Why? On Earth, if you are talking, if you are saying like on Earth a feather floats because it is light and has a relatively large surface area, so air resistance easily overcomes its weight. But in a vacuum, the only force acting on it is gravity. There is no air resistance. Since gravity accelerates all the objects at the same rate, that is 9.8 meter per second, it is the speed, you can say, value of g, it is gravitational constant. It is your gravitational constant, it is 9.8 meter per second square. And with this speed, gravity pulls all objects towards itself, towards the earth, and they stay side by side all the way to the ground. And this is what that famously proven as well by Apollo astronauts David Scott on the moon. Like where there is no atmosphere, he dropped a hammer and a feather together, and they hit the lunar surface, the moon's surface, at the exact same moment. Actually, what he has done, astronaut David Scott dropped a feather and the hammer on the moon, and he got the result that they hit the ground at the same time. But why? Because the moon has no atmosphere, no air to resist motion, and gravity alone acts equally on all objects, and both fall together. No air, no air resistance, you can say, and only gravity acting on it with the speed. Here the g will be used as a constant, that is gravitational constant, and its value is 9.8 meter per second square. So by having a comparison of these two, like on earth, how the objects are falling when there is air resistance, and in vacuum when there is no air resistance, what is the difference between them? A feather falls slowly than hammer if you are just dropping a feather and a hammer side by side. Why it is so? Air resistance affects the feather much more, and it hits the ground later as compared to the hammer, because the feather has a large surface area but very less mass. Less mass means its gravitational pulling force is very less, very minimum, and it has a larger surface area, it has greater air resistance. Now when it is pulling towards the earth with a very weak force and having a large surface area and there is lot of air resistance, that is why its speeds slows down. While hammer is very heavy, hammer is having a greater weight, much more weight as compared to the feather, so air resistance has less effect on it. How? Because now what is basically its, if it is heavy, so basically it's having a greater weight and greater gravitational pulling force, so it overcomes the air resistance because it has less surface area as compared to the feather, you can say, and having a much greater mass, or the much greater weight. So the heavier objects falls faster on the earth. Why? Because air resistance has less effect on them due to their heaviness. But this is only because of the air resistance. When there is no air resistance, when the objects are falling in the vacuum, then they comes towards the earth, they drop to the ground at the same moment with the speed 9.8 meter per second square. So in a vacuum, there is no air, no air resistance, and all objects fall at the same rate. Means mass doesn't affect falling speed. Mass doesn't affect falling speed. Gravity pulls all the objects equally. Got it? Gravity pulls all the objects equally, and a feather and hammer fall together. Got it? Like on your earth, the gravitational pull is equal for your feather and for the hammer. But what is the difference? What makes that the hammer hits the ground before or earlier as compared to the feather? Due to having a less surface area as compared to feather, due to having less air resistance as compared to feather. Got it? So heavier objects always fall faster. That is false. This is a misconception and you will have to clear it. They only fall faster when air resistance is present. In a vacuum, all objects fall at the same rate. So Galileo was also right, and he said that all objects fall at the same rate. It's air resistant that makes things seem different on earth. Next is what we have done as a whole. That was the you can say what we have learned. It's a conceptual summary or a big picture of today's lesson. So we have learned about key concepts. Those were air resistance, that is the friction opposing motion through air, and it depends upon three different factors. We have learned about speed, surface area, and shape. Higher speed, greater surface area, and shape, if it is not streamlined, then having a greater air resistance. But if it is having low speed, low speed, less surface area which is in contact with the air, and having a streamlining shape, it will have a less air resistance. And terminal velocity, what it is, when air resistance becomes equals to its weight, the object is able to get its terminal velocity. And vacuum means there is no air resistance and all objects fall together at the same time. We have learned about the different applications like streamlining in cars, planes, cyclists, fish birds, as well as we have learned about the wind tunnel, where the streamlined cars and planes are manufactured using air resistance, like how parachutes are using it as a positive way, aircraft flaps and rocket car braking system, how they are using in a positive way, and how we are able to reduce air resistance. Like I have also told you the example of a cyclist when he crouches towards the handle. So crouching and special helmets they are wearing to make them a streamlined shape, as well as braking. I have already told you rocket car parachutes, which increases the air resistance, surface area increases, and their speed slows down. Next is what you people will have to be in your mind. These three things, like air resistance increases with increasing in speed, with having a greater surface area, and by having no streamlining shape. And terminal velocity, what it is? Terminal velocity means when weight, which is acting downwards, and air resistance, which is acting upward, when they both of them equalizes themselves, equal हो जाती हैं, then the object is able to get constant speed. And in a vacuum, no air particles, no air resistance, and all objects fall at the same rate. These are the summary key formula that you people must have in your minds clear. Next, moving towards your questions that are given in your books as well. So question number 1, that car manufacturers put cars in wind tunnels to design streamlined cars. Explain what is meant by streamlined and which experiences more air resistance, a streamlined car traveling slowly or a lorry traveling fast. You will have to explain these things. So firstly, is your question, that is streamlined. What does it mean? Streamlined means having a special shape that allows air to flow smoothly over it with minimal turbulence, and a streamlined shape reduces air resistance by changing the flow of air over the object, allowing it to move through the air resistance more easily. Got it? You can write it the same answer. This is the model answer for your question. It will become easy to prepare for you. Which experiences more air resistance? What do you think? A streamlined car traveling slowly having a more air resistance? But according to you, it would experience a more air resistance, or a lorry which is traveling very faster? Lorry means having a truck and the vehicle which is having a greater surface area. Fine. Obviously, the lorry traveling fast would experience more air resistance. Although the streamlined car reduces air resistance and the lorry is at much higher speed, air resistance increases with speed as well, and a faster object pushes air more. The air comes in its way, it is pushing it more out of the way, and the high speed with outweighs the streamlining. High speed outweighs the streamlining. Now you have to tell all these 3 points for a single this question. Got it? Next questions, which is also from your book, bete. Explain why tennis ball and a cricket ball dropped together will hit the ground at about the same time, even though the cricket ball is heavier. Assume they are about the same size as well. Now what is examiner want to know? That firstly he tell us what he has told us, like explain why a tennis ball and a cricket ball dropped together will hit the ground at the same time, at the same moment. Though the cricket ball is heavier, tennis ball is not heavier as compared to the cricket ball. Assume they are about the same size. Their size is same, means their surface area is same, and cricket ball is heavier, but they are hitting the ground at the same moment. Why? Both balls are about the same size, same surface area, so they have the same surface area and therefore experience approximately same amount of air resistance. First thing is that since the cricket ball is heavier, the force of air resistance has much smaller effect on it as compared to its weight. However, because the tennis ball and the cricket ball are similar in size, the air resistance acting on each is similar, and both are affected by air resistance in a comparable way, in the same way. Now, both are having a same air resistance, you can say. So, the difference in mass is not large enough to create a noticeable difference in falling time when they are having a same size. If dropped in a vacuum, they would fall at exactly the same rate because there would be no air resistance at all. Fine. This is the extra thing that you can say, like in vacuum, because according to your question demand, it is not mentioned that how they are going to move in the vacuum. Got it? The last line I have given you it as an extension, extra material for the question as well. Got it? Now moving towards your workbook. So different okay, so you will have to open your workbook as page 75 as well, that is air resistance, and use the words and phrases from the box to complete the sentences below. Use each word or phrase once, more than once, or not at all. The words given over there are air resistance, constant, decreases, friction, faster, slower, and streamlined, while the blanks are the forces of dash and dash tend to slow moving objects down. So forces of, what do you think? Forces of, yes, force of friction and air resistance. The forces of friction and air resistance slows moving objects down. Air resistance is bigger if an object is moving dash. Air resistance is bigger if the object is moving faster, and you can use lubrication to reduce the force of friction and reduce air resistance by making the object more streamlined. Got it? Now come towards their answers. I have just mentioned over there. The forces of friction and air resistance tend to slow moving objects down. Air resistance is bigger if any object is moving faster, and you can use lubrication to reduce the force of friction and reduce air resistance by making the object more streamlined, or by making the object more faster. But the exact and confirm word will be streamlined. Streamlining shape moves faster. The sentence below describe the forces acting on a parachutist, and from the moment that she jumps off the plane until she lands, but they are not in the sequence given to you is not correct. Got it? Different A, B, C, D, E, and F. Like in A, when the air resistance is equal to the weight, the parachutist will travel at a steady speed, called the terminal velocity. Next, the thing given to you is the parachutist is traveling slowly so she can land safely. The air resistance increases as she accelerates. Next is the parachutist opens her parachute. The air resistance suddenly increases, so the parachutist suddenly slows down, and the air resistance increases until it equals the weight of the parachutist, and she reaches a low terminal velocity than before. As the parachutist jumps out of the plane, she accelerates. So these different sequences, these different situations are given to you, but they are not in the sequence. So if we make them a proper sequence, what it will be like, for that you must have first thing is that as the parachutist jumps out of the plane, she accelerates. First thing is G, you can say from your books, but I think G is missing from there. Next is the air resistance increases as she accelerates. Now the part C according to your books. Next it will be when the air resistance is equal to the weight, the parachutist will travel at a steady speed called terminal velocity. It will be A now. After that, the air resistance increases until it equals the weight of the parachutist and reaches a lower terminal velocity than before. It will be F. Next, the parachutist open her parachutes, it's D, and the air resistance suddenly increases, so the parachutist suddenly slows down, it will be E, and then the parachutist is traveling slowly so she can land safely. So according to your workbook material from A to G which are given over there, the actual sequence will be G, C, A, F, D, E, and B. Got it? The next question, which is given to you, explain why birds take on streamlined shape to dive into the water and catch fish. And you also have how you people are able to get the answer. Think about what does streamlining do to air resistance or the water resistance, and how does this help the bird to hunt his or her its prey. Yes, the answer is given to you. Birds streamline to reduce air or water resistance, and the streamlined shape allows water to flow smoothly over the bird's body, reducing drag. This lets the bird move faster through the water to catch the fish. Next is explain why the large parachutes slow you down more than small parachutes. Explain why large parachutes slow you down more than small parachutes. Now, it's very obvious having a think about how does the surface area affect the air resistance. What is the relationship between surface area and the drag force or the air resistance? You people can easily get the answer. So what it is, large parachutes have greater surface area. So the greater surface area means more air particles are collided and creating more air resistance, and this greater opposing force slows the parachutist down more than a small parachutes. Got it? Now the next question, which is given to you as your extension, draw a diagram showing the force acting on a piece of paper being dropped on the being dropped on the earth and on the moon. Now how you have to draw those forces diagram, like earth is weight is pulling the substance or the object downward, plus air resistance is over there also, while on moon only weight is acting on it downward and there is no air resistance. Got it? So in earth there are two arrows will be there, weight, and the weight's arrow will move downward and air resistance arrow will act upward. Got it? While on moon there is only one force is acting, that is weight, it will be towards downward. Next is in 1971 an astronaut called David Scott, he did an experiment on the moon. He dropped a hammer and a feather together and they hit the ground at the same time. I already have explained this in your previous lecture slides. So the moon experiment, what it was, there is no atmosphere. No atmosphere means having no air resistance, only gravity acts over there and accelerating all the objects equally, pulling getting towards the earth. They are pulling towards the earth with the same speed. So hammer and feather fall at the same rate at the same moment. Got it? So with this we just come to an end of today's lecture. Learn all these things very well, make clear your concepts, complete your workbook material, and prepare it well for the tomorrow's test. Stay blessed. Allah Hafiz.